Something changed over the Pacific, and it is already beginning to reshape the weather pattern across the United States. Not in the way a single thunderstorm changes your afternoon. This is much larger than that. It is happening thousands of miles above you, across the jet stream, while another part of the story is unfolding thousands of miles away beneath the surface of the tropical Pacific Ocean. And right now, those two pieces are beginning to work together. El Niño is strengthening. A powerful ridge of high pressure is building over parts of the southern United States. Forecast models are increasingly showing the potential for a long-lasting heat pattern across the south and parts of the central country. At the same time, other parts of the United States can experience a very different kind of weather as the jet stream bends around this enormous atmospheric setup. NOAA is currently warning that a potentially major and long-duration heat event could develop across portions of the southern tier, while rapid-onset drought is also becoming a concern in parts of the plains and Mississippi Valley. And the reason this matters is that the atmosphere is not a collection of separate weather systems. It is one connected machine. Something happening over the Pacific can influence the jet stream. The jet stream can reshape pressure patterns thousands of miles away. Those pressure patterns can determine where storms form, where heat gets trapped, and where dry air begins to dominate. That is why a change you cannot see from your backyard can eventually decide whether your next week feels like late summer, early autumn, or something much more extreme. And the biggest question right now is not simply whether the weather is going to change, it is how long this new pattern can hold. To understand that, we have to start with the Pacific. El Niño is not a storm. It is not a hurricane. It is not a cold front moving across the country. It is a large-scale warming of the tropical Pacific Ocean that changes the relationship between the ocean and the atmosphere above it. And this year's event is becoming unusually important. NOAA's latest guidance shows El Niño continuing to strengthen with an unusually high probability of a very strong event during the northern hemisphere fall and winter. Earlier, NOAA guidance put the chance of a very strong El Niño during October through December at 81%, and the August outlook continues to show El Niño as the dominant state rather than a brief, temporary disturbance. That does not mean every place in America automatically gets the textbook El Niño weather pattern. That is an important distinction. Climate patterns change the odds. They do not control every individual storm. A strong El Niño can make certain outcomes more likely, but it does not guarantee that every region will experience those outcomes in exactly the same way. NOAA itself emphasizes this point when discussing strong El Niño events. But something fascinating happens when the tropical Pacific becomes unusually warm. Thunderstorm activity near the equator changes. Those thunderstorms release enormous amounts of heat into the atmosphere. That heat alters atmospheric circulation, and eventually those changes can influence the jet stream far away from the Pacific. Think of the jet stream as a giant river of fast-moving air circling the northern hemisphere. It separates different air masses and helps guide storms from one region to another. When the jet stream is relatively straight, weather systems can move quickly. But when large areas of high and low pressure become established, the jet stream can bend into enormous waves, and those waves can become persistent. That persistence is what makes a blocking pattern so important. Normally, weather moves, a high-pressure system arrives, it spends some time over a region, then it moves away. A storm arrives, it passes through, another system follows, but sometimes the atmosphere gets stuck. A large ridge of high pressure can build and remain in place for days. The jet stream has to flow around it. And when that happens, the same weather conditions can repeat again and again. If the ridge sits over a region already experiencing heat, each additional day can make the problem worse. The ground dries, the soil loses moisture, plants release less water into the atmosphere, and the land becomes less capable of cooling itself. That is one reason heat and drought can begin reinforcing each other. And right now, that is one of the most important developments across parts of the southern and central United States. NOAA's August 19th hazards assessment describes a potentially major and long-duration heat event developing across the southern tier, with especially concerning signals from the desert southwest through the Great Plains. The agency also highlights rapid-onset drought concerns in parts of the central and southern plains and the Mississippi Valley. So while the atmosphere is changing, the first thing to understand is that this is not necessarily a story about one giant cold front sweeping across America. The stronger confirmed signal right now is almost the opposite. Heat is trying to establish itself, and once a ridge becomes dominant, the atmosphere can begin repeating the same weather day after day. Imagine putting a lid over a pot. The heat does not have an easy way to escape. That is roughly what a strong ridge can do to the atmosphere. Air sinks beneath high pressure. As it sinks, it warms. Cloud formation becomes more difficult. Rain becomes harder to produce, and sunshine continues heating the surface. The result can become a feedback loop. More heat, less rain. Drier soil, more heat. And that is why a heat wave that lasts several days can become much more dangerous than a single hot afternoon. The human body gets less opportunity to recover. The electrical grid faces sustained air conditioning demand. Agriculture loses moisture. Wildfire conditions can worsen in already dry areas, and water resources come under additional pressure. But there's another part of this pattern that makes it especially interesting. The country does not experience a massive ridge in exactly the same way everywhere. Weather patterns are often divided. While one region sits beneath rising air and intense heat, another region can sit beneath a trough where cooler air is able to move south. That means two people living hundreds or even thousands of miles apart can experience completely different weather at exactly the same time. One person may be asking when summer will finally end, another may be asking when the heat will finally break. And both can be looking at the same national weather map. That is because the jet stream is doing the dividing. As the large-scale ridge expands, the flow around it can create troughing elsewhere. And that is where the uncertainty becomes important. Forecast models do not always agree perfectly on exactly where the ridge will settle, how strong it will become, or how long it will remain in place. That uncertainty is normal. It does not mean forecasters have no idea what is happening. It means the broad pattern can be more predictable than the exact local outcome. Meteorologists can be reasonably confident that a large-scale ridge is developing while remaining uncertain about the temperature in one particular city 10 days from now. That is why a responsible forecast should never turn a probability into a guarantee, and it is also why the latest model runs matter so much. Every new observation gives the models another piece of information. Every day, they recalculate the atmosphere. Sometimes the pattern becomes clearer. Sometimes the models back away from the most extreme scenario. And sometimes they move in the opposite direction. That is exactly what makes long-range weather so difficult. The atmosphere is chaotic. Small differences today can become larger differences several days later. But large-scale patterns can also create stability. Once a strong ridge or blocking pattern becomes established, the atmosphere can sometimes remain remarkably persistent. That is what forecasters are watching now, not just tomorrow's temperature, not just Friday's thunderstorms. The question is whether the large-scale pattern has enough strength to keep reproducing the same conditions. And that brings us back to El Niño, because this is where the story becomes bigger than one heat wave. The Pacific Ocean is enormous. When a huge section of it becomes significantly warmer than normal, it changes the source of heat and moisture entering the atmosphere. The atmosphere responds, the jet stream responds, storm tracks respond, and the effects can eventually reach North America. This is one reason NOAA is paying so much attention to the strengthening El Niño heading into the fall and winter. Current official guidance shows El Niño persisting and strengthening, with the potential for a very strong event that could rank among the strongest in the historical record. But again, strong El Niño does not mean every place becomes hotter. That is not how it works. It changes the probabilities of certain atmospheric arrangements. And those arrangements can interact with whatever pattern is already developing. That interaction is the real story. Because the weather over America right now is not being controlled by one single switch. It is the result of several systems interacting. The tropical Pacific, the jet stream, high-pressure ridges, low-pressure troughs, soil moisture, storm tracks, and the position of the major air masses. When those systems line up, the weather can become unusually persistent. And persistence is what we should be watching. A heat wave lasting one day is uncomfortable. A heat wave lasting 1 week can become dangerous. A heat wave lasting even longer can begin changing the landscape itself. The ground becomes progressively drier. Vegetation becomes stressed. Fire danger can rise. Reservoirs and rivers can face additional pressure. And communities that were prepared for a few hot days may suddenly find themselves dealing with something much longer. That is why the phrase rapid-onset drought matters. Drought does not always begin with months of obvious dryness. If temperatures rise sharply while rainfall remains limited, soil moisture can disappear surprisingly quickly. And once the soil dries, the atmosphere can become even hotter near the surface. The land has less moisture available for evaporation. Less evaporation means less natural cooling. So the same amount of sunlight can produce a stronger temperature response. That does not mean every hot day creates a drought, but when heat and dryness arrive together, the transition can happen quickly. And NOAA is already highlighting this risk in parts of the central and southern plains and the Mississippi Valley. There's another thing people often miss about a pattern like this. A heat dome does not necessarily mean there are no storms. In fact, the boundary between extremely hot air and cooler air farther north can become an active zone for thunderstorms. That boundary is where different air masses collide. Warm, humid air rises. Cooler air pushes underneath it. The jet stream provides additional energy higher in the atmosphere. And suddenly, a region that was extremely hot can become the stage for severe weather. That is why weather can feel contradictory. You can have dangerous heat in one state and severe thunderstorms a few hundred miles away. The atmosphere is not confused. It is responding to the geometry of the larger pattern. And that geometry is changing. The important thing is that the strongest current signal is not necessarily a single nationwide event. It is a split, a division, a large ridge dominating the southern part of the country while other regions remain influenced by different parts of the jet stream pattern. And that split can become very important as we move toward September, because the calendar is about to change. Late August is usually a transition period. Summer is still powerful, but the northern hemisphere is slowly losing solar energy each day. The nights begin getting longer. The angle of sunlight changes, and the atmosphere becomes increasingly sensitive to the first major pushes of cooler air from the north. That does not mean autumn arrives everywhere at once. It means the ingredients for seasonal change are beginning to become more important. If the ridge remains dominant over the south, summer heat can continue there even while other parts of the country begin feeling increasingly autumn-like. That is one of the strangest things about a large blocking pattern. It can make the country feel like several seasons at once. One region gets record heat, another gets thunderstorms, another gets cooler nights, another gets unusually dry conditions, and all of it can happen under the same enormous atmospheric wave. So what should you actually take away from this? First, the developing pattern is real. NOAA is currently highlighting a potentially major and long-lasting heat event across parts of the southern United States, while rapid-onset drought is becoming a concern in several areas. Second, El Niño is strengthening. That is not speculation. It is an observed ocean atmosphere pattern, and NOAA expects it to continue strengthening into the northern hemisphere fall and winter. Third, the exact local outcome is still uncertain. A strong, large-scale pattern does not tell us exactly what every city will experience. The ridge can shift. The trough can deepen. Storm tracks can change. And model forecasts will continue adjusting. Fourth, the most important thing to watch is persistence. If the ridge remains established, the heat and dryness can reinforce each other. If the ridge weakens or shifts, relief can arrive faster. That is the difference between a short-lived hot spell and a major long-duration heat event. And finally, this is why I would be careful with dramatic headlines claiming that the entire country is about to experience some single historic weather event. The real story is more interesting. America is entering a period where the atmosphere is becoming increasingly divided. The same large-scale circulation can produce extreme heat in one region and a completely different weather regime somewhere else. And underneath that pattern is a warming tropical Pacific that could become one of the dominant climate signals of the coming seasons. The atmosphere is essentially rearranging its pieces. The Pacific is supplying one signal. The jet stream is responding. High pressure is strengthening. Heat is building across parts of the south. Dryness is becoming more concerning in some regions, and the northern half of the country remains vulnerable to sharp changes whenever the jet stream shifts. That means the next few weeks could be very different from what many people expected when August began. Not necessarily because one enormous storm is coming, but because the atmosphere is beginning to settle into a new configuration. And once the atmosphere settles into a pattern, it can become surprisingly stubborn. The most important question now is how strong that pattern becomes, how long it lasts, and where the dividing line between heat and cooler air eventually sets up. Those details will determine who gets relief, who stays under dangerous heat, where drought expands, and where storms become the next major concern, and that is the part we will be watching. Because weather forecasting is not about pretending we know everything. It is about recognizing the signals early, understanding what they mean, and being honest about what remains uncertain. Right now, the signal is getting stronger. El Niño is strengthening. A major ridge is becoming established over parts of the southern United States. NOAA is warning about potentially long-duration extreme heat, and rapid-onset drought is becoming a growing concern in portions of the plains and Mississippi Valley. The pattern is not finished developing. That may be the most important sentence in this entire video. The forecast you see today is not the final forecast. The atmosphere is still moving. The ocean is still influencing the atmosphere. The jet stream is still adjusting. And every new model run will tell us a little more about where this pattern is headed. So if you are living under the heat right now, do not assume that one cooler day means the pattern has completely broken. And if you are in a region finally getting some relief, do not assume the entire country is experiencing the same thing. The bigger picture is much more complicated. This is a weather pattern dividing the country while the Pacific Ocean quietly strengthens the signal behind it. And as we move toward September, that distinction could become even more important. If you want weather explained without the hype, without turning every model run into a disaster, and without pretending that uncertainty doesn't exist, subscribe to WideView. We will keep following the atmosphere as this pattern develops, because the next few forecast updates could tell us whether this becomes a temporary late summer setup or something much more persistent. And if you're already feeling the change where you live, tell me in the comments what you're seeing. Are you dealing with dangerous heat? Are storms moving through? Are temperatures finally starting to fall? Because the country is experiencing very different versions of the same atmospheric pattern right now. And the next few weeks may reveal just how far this pattern is capable of reaching. The atmosphere has started rearranging itself. Now we watch to see where it settles.